Let's take a look at the components of the Triax 2A motion control system. The system consists of an integrated controller driver, 3 stepper motors, and the software interface, and is designed to work right out of the box. Here we can see the Triax 2A used to retrofit a manual tabletop milling machine. The software is designed to run on Windows 7 and has a user-friendly graphic user interface to support CNC operations via G-codes. The sculpture shown was machined using the Triax 2A system from an existing G-code program. This video describes the Triax 2A controller. Triax 2A is a 3-axis coordinated motion controller with 3 built-in power drivers capable of driving up to 2 amps into bipolar stepper motors. The Triax 2A system is designed to retrofit a mini mill or a tabletop mill with 3 stepper motors. The system provides basic I/O control and an open-loop spindle speed and direction signals. The controller hardware connects directly to 110 or 220 volts AC, thus requiring no external power source. The controller also provides inputs for limit switches, which when activated will stop an axis from continuing motion. The Triax 2A is designed to provide state-of-the-art USB-based real-time motion control as opposed to many existing parallel port controllers. A generous FIFO memory stack provides smooth profile blending, thus enabling contoured circular and helical interpolation. The intelligence behind the hardware is provided by a 64 MHz digital signal controller and a dedicated multi-axis trajectory and step generator chip. 3 power modules provide all the signal to power translation needed to drive the 3 stepper motors directly. All components are mounted on an FR4 75 by 150 mm PCB. Power modules are fan cooled. The motor shown is a NEMA 23 1.2 Nm holding torque and are also the ones used in retrofitting the tabletop machine shown. Going up the command chain, the hardware intelligence is commanded by the Triax 2A Profile Cut application. This application was developed in Windows 7 and is shown running on a laptop powered by an AMD Athlon 2.2 GHz. OS is Windows 7 Home Premium. The Profile Cut application provides a user-friendly graphic user interface that internally configures the system in 4 different modes. The first is the diagnostics and machine setup mode. This mode lets the user configure the software and the hardware to be in tune with the mechanical motion parameters like the gear reduction, stepper motor capabilities, lead screw pitch, etc. The application uses these values to perform all the calculations necessary for running the system correctly. The second mode is the semi-auto mode. In this mode, the user enters the motion parameter values for each profile using the graphics screen. This provides a very intuitive and easy method of getting started and running the basic profiles. More complex profiles may be run using the built-in motion macros like the drill and the mill macros. The third mode is the automatic mode or the auto mode. This mode provides a window for the user to type in an RS-274D G code or simply open a text file containing one and run the motors. The G-code interface runs an error check before running the program and flags any syntax and common logic errors which may otherwise run the machine into an unacceptable condition. In semi-auto or auto mode, the profile cut may also be put in a pendant mode to gain full manual control over the machine. This mode allows the machine to be jogged using a software pendant while giving access to the position registers in the controller. The user can now set the values of the axis position as he deems necessary. Other functions available are macros to locate the center of a circular feature, coolant on-off, and some future functions. The user can also choose to open the tool offset page, giving direct access to the tool database. Alternatively, the user can exit the application altogether by clicking on the Exit button. This video shows all the components of the Triax 2A assembled to run a tabletop mill machine. The system is configured for auto mode operation and will show the helical interpolation with contouring.